I had an idea for how we could have one cylinder power different muscles, and this is how. So the cylinder pulls on, the way we drew it, this is the output of the cylinder, and we have a string tied to it, and that's the muscle string. Now that can be woven metal for a really strong string, or it could be fishing line. It could be whatever kind of string we find we need to handle the amount of tensile force generated. Okay, now I was thinking all you'd have to do to enable the same cylinder to power a different muscle is untie this string and tie on a different string for a different muscle. We'll have that hook come through a hole and actually the hole would be more like that. Alright. So when it's pulled through, this hole's flush, nothing can touch it. And then we're going to put a ring across the hole. And that ring will tie to a string which leads to a muscle. And then we can have another ring next to it. Okay, and the second ring could be slid into place. So you can slide this ring that way with a servo pulling it. Alright, the servo pulls it that way. And then another servo could pull this ring into place, pulling it that way. So depending on which ring you line up with this hole, when you push this hook up, it's going to come out of the hole, and then you can seat the ring into the hook and then pull. So that whole thing would look like this when you shift it. So you would have ring number 1 moved over, and then ring number 2 moved into place, and the hook could then be seated onto the ring, and so now I'd pull on that one. And so based on where the hook ends, so you can shift different rings into position to be pulled by the hook. And then actually no, the hook doesn't have to be in a hole. I take that back. The hook can be just moved in the z-axis out of the way. It can just be rotated that way. So the hook can be like just brought over. Okay. So the hook can have a string that just pulls it with the motor. So if the hook is brought that like down, it wouldn't be in alignment with the ring, and so the rings can shift over. And so then this muscle that's connected to this ring will be lined up with the hook, and then the hook can be brought forward. So it'd be like this. I'll show you with my hands. So there'd be like 2 rings and a hook. So the hook can be like that, and it can pull. Then it can be, so it can do that, and then a motor can make it go back, Another ring can slide into place. There can be several rings. That ring is slid to here. The hook is brought forward, pull. Move it out to shift. A different ring comes into position, move it in, pull. And so you can have a shifter system that enables you to line up different muscle rings with the output of your piston of your combustion actuator. So instead of only it being able to pull one muscle, it can be responsible for different muscles. And so in that way, maybe the same actuator could be in charge of bicep curls and the opposing muscle tricep. And then the same actuator can be in charge of the hamstring and the quadricep of a leg just by shifting. So that's a cool way to enable more efficient use of these combustion actuators, because we can't fit that many of these. They're going to be hot, they're going to take up space, they're going to require a lot of piping and parts, they're going to be hard to make. So we want to not have to make too many. And this just will save space by using the same actuator for multiple muscle groups. You can save space with one actuator responsible for a group of muscles, but the shifter system will take a lot of space. I disagree. These little rings, I drew them much larger than they need to be. Each ring and the hook can be tiny, tiny. I mean, we're talking like the string will probably be kind of thick. And then the hook can be like this. That's to scale. So like a quarter would be there's a quarter. That's how small it is. Tiny. Tiny, tiny. That's how small the shifter system can be. So, yeah, I disagree that it would take a lot of space. This can be super small scale. The servos are just going to be pulling the hooks left and right. And a servo, so like the control board for a servo is about that big, and then the servo motor is about that big for the tiny. And I separate the motors from the servo, or I separate. When I buy a servo, I take the motor and the control circuitry out of the box, and I get rid of all the gearing. You don't need the gearing for this. So you're looking at about that big. Like, here's it next to my thumb. Tiny. Tiny little servo compared to my thumb. Tiny servo, tiny servo controller.